Chapter then, section 5.1 is perpendicular and angle bisectors. So we're just going to go through some notes today, get some definitions down, do a few example problems here, and then we'll call it a day. So first for your notes, should have perpendicular and angular bisector. That should be kind of your heading. That's what we're talking about today. This is section 5.1. This is section 5.1. So first definition we have is a perpendicular bisector. A perpendicular bisector of a segment is a line, a segment, or a ray or a plane that is perpendicular to a segment at its midpoint. Okay, so a perpendicular bisector of a segment is a line, a segment, a ray, or a plane that is perpendicular to the segment at its midpoint. So perpendicular means to meet at 90 degrees. We've talked about perpendicular a lot in here. Perpendicular means to meet at 90 degrees, and bisect essentially means to cut in half. So it's taking a segment. If I draw it over here on the side, because it's the only place I really have to draw on this. If we have a segment, so this is our segment, a perpendicular bisector to that segment is going to meet at a 90-degree angle. That's the first thing that it does. That means it's perpendicular. But it also cuts this into two congruent pieces because it meets at the midpoint right there. So that's what a perpendicular bisector is in general. And we can put perpendicular bisectors on triangles. But again, what it's going to do, it's going to meet at a 90-degree angle, and it's going to cut the segment or whatever it intersected at its midpoint, breaking it up into two congruent pieces. That's what a perpendicular bisector is going to do. It's going to meet perpendicular, and it's going to cut in half. So if the measure of this side is 3, the measure of this side also has to be 3 if it's a perpendicular bisector. And obviously we know both of those angles then have to be 90 degrees to each other. So that's a perpendicular bisector, just to get some definitions out of the way. Next definition is an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So an angle bisector is a ray that divides an angle into two congruent angles. So again, I don't have much space on this thing, unfortunately. But if I look at an angle bisector, if I take an angle, we've talked about angle bisectors in the past, an angle bisector is a ray that divides our angle into two congruent pieces. And we've talked angle bisectors before. This isn't new. Okay. So if the measure of this angle is 20 degrees, the measure of that angle is 20 degrees as well. So those are just two general definitions of what perpendicular bisectors are. Now, perpendicular bisector itself does something that's pretty unique. And that's the perpendicular bisector theorem. Perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, and writing all this down isn't going to make much difference to you guys. It's more important that you draw the picture. But what that means is, so I've got this point right here, P, that's on this perpendicular bisector to this segment. Okay, and I know that because that's a 90-degree angle, and these two pieces are congruent to each other. So if that happens, then that point P is equidistant from the endpoints of the segment that it was a perpendicular bisector to. So on this drawing, PM is a perpendicular bisector to AB. So we've got our 90-degree angle, and we've got AM is congruent to MB. When that happens, then PA, this distance right here, is congruent or equal to the distance from P to B. But in order for all of this to be true, this has to be a perpendicular bisector to AM. And it doesn't matter where I put this point on this perpendicular bisector. I can put this point down here on this perpendicular bisector, and I can call that point L. If I draw a line to each of the endpoints of the segment that it bisected, those two pieces are going to be congruent to each other. Okay. Kind of think about it like this. If I'm going to run from Ellis, or from the high school, and I'm going to have somebody run the exact same speed as me from Ellis. So the high school and Ellis are my two endpoints. Okay, if we run the same speed, we're going to meet at the midpoint. Okay? Now, if I say that I'm going to take a 30-degree angle, and they're going to take a 30-degree angle from Ellis, and we're going to meet, if we go the same distance because we're going the same speed, we're going to meet on that perpendicular bisector because we're traveling the same distance. It doesn't matter where I put this point on this perpendicular bisector. The distance from those 2 points is always going to be the same. Okay? And we'll do several problems that talk about that in just a second. Okay? So if we have a perpendicular bisector theorem, then we also have a converse to the perpendicular bisector theorem. Okay? So again, you don't really need to write the whole thing. Just put converse of the perpendicular bisector theorem. The converse says if a point is equidistant, and just kind of remember what converses do. We talked about conditional statements. We talked about converses, inverse, and contrapositives. We said that the converse essentially took our conditional statement and changed the hypothesis in the conclusion. So this says if that point is equidistant. So if P is equidistant from A and B, so those two pieces are congruent. If that happens, then PM is going to be a perpendicular bisector of AB. So if these two are congruent to each other, then PM has to be a perpendicular bisector of that segment. So PM is perpendicular to AB, and AM is going to equal MB. So then these two pieces are congruent to each other. Just the converse of the statement that we just made. So that's what it means to be a perpendicular bisector. Okay? It bisects at a 90-degree angle. The segment opposite it, breaking it into two congruent pieces. And then any point on that perpendicular bisector, if you draw lines to those endpoints, they are going to be equal to each other. So if we're looking at examples of this, okay, we've got this drawing here for example number 1. It's telling us to find the value of x. And here's what we're given. We're given, let's call this triangle ABC. I'll give that an A, I'll give that a B, and I'll give that a C, and I'll make this point right there D. It's telling me that segment AD is equal to segment DC. That's given to me. It's also telling me that BD is perpendicular to AC. That's what that 90-degree angle means. So that tells me that this is a perpendicular bisector. So because that's a perpendicular bisector and B is on that perpendicular bisector, the distance from A to B has to equal the distance from B to C. We know the distance from A to B is 4x. We know the distance from B to C is 6x minus 10. So now we can find the value of x. Subtract 6x from both sides. That gives us negative 2x equals negative 10. Divide by negative 2. We get x is equal to 5. And if that's what they ask you for, that's what they ask you for. If you're asked what's the distance from A to B, what does AB equal? Well, it's just 4 times 5, which is 20. And that's what it means to be a perpendicular bisector. It means that those two lines are congruent to each other. Okay, and it doesn't make a triangle, sure. It makes a triangle in this case. It does make that triangle. Okay. So we got a second example, which we can't do yet. Oh, here we go. Okay. Example number 2. So in this example, again, I'm going to go A, B, C, and D. It's telling us that AB is equal, because of our tick marks, BC. We also have that BD is perpendicular to AC because of our 90-degree angle. If that happens, we've got a perpendicular bisector. AD has to equal DC. So 12x minus 3 has to equal 4x plus 13. That has to happen. So subtract 4x from both sides. Then add 3. So you get 8x equals 16. X equals 2. And you're done. Okay. Any questions with that second example? Okay, go ahead and see if you can find now this distance from EH and EG. You can find the distance from EH and EG. Means find the value of y. Once you've found the value of y, then go ahead and just substitute it in. Okay, so we've got these two pieces are congruent to each other. So if this one's 4, this one has to be 4, right? And they ask us for the distance from E to H and E to G. So E to G is this distance right here. That distance is just going to be 8. Now, because that's a perpendicular bisector, then we know that EH has to equal GH. So 6y minus 2 has to equal 8y minus 10. I'm going to subtract 6y from both sides and add 10. That gives me 8 equals 2y. Divide by 2, you get y is equal to 4. He wants to know the distance from E to H, which is right here. So we know y is 4, so I can substitute it in there. 6 times 4 is 24. 24 minus 2 is 22. There's our distance from E to H. There's our distance from E to G. Questions with that one? Just find FG. Just find FG. Don't worry about finding the measure of the angle yet. Oh, we could find the measure of this angle. It gives it to us, I guess. We could do both. Find FG and find the measure of EGH. Okay, so because these two pieces are congruent to each other, that makes this a perpendicular bisector. So the measure of that angle is 90 degrees. So EGH is 90. And then FG has to equal GH. So 2x plus 20 equals 14x minus 28. Subtract 2x from both sides. Add 28. So 48 equals 12x. Divide by 12. X is 4. But it wants to know from F to G. So 2 times 4 plus 20. 8 plus 20 is 28. Any questions so far with perpendicular bisector questions? So the next thing we're going to look at then is we're going to look at, and we'll talk about that one in a minute. We'll talk about that one tomorrow. Next thing we're going to look at then is we're going to look at the angle bisector theorem and its converse. Okay, so we've got the perpendicular bisector one taken care of. Now we got to take care of the angle bisector theorem. And again, writing it all down, probably do the drawing. Drawing makes more sense. The angle bisector theorem, just draw that picture. It's easier just to describe it on the picture. Give me a second to draw that, then I'll zoom out. So what the angle bisector theorem says is it says this, that if a point is on the bisector of an angle, then the point is equidistant from the side of the angle with the condition. Okay? So I've got this point right here, D, that they're saying that's on this angle bisector. And I know it's on the angle bisector because these two pieces are congruent to each other. If the distance from that point to the rays that make it up, if that is perpendicular, so in this case, AB is perpendicular to BD, and AC is perpendicular to CD, and this is the whole key for this. These have to be perpendicular to the sides of the angle that's creating it. If that's the case, then, and only then, is BD congruent or equal to DC. And again, the key to this has to be a 90-degree angle. And again, I can pick any point on this angle bisector, just like I could on that perpendicular bisector. But now, when we draw it to it, these have to be perpendicular. If they're not perpendicular, this does not work. Okay, then these two would be congruent to each other. If I put a third one here and I drew a line there, and this one's perpendicular and this one's not, they're not equal to each other. They have to be perpendicular to the side. If they're not perpendicular to the side, they're not congruent to each other. Okay? Now, the converse of it, and we're just going to talk about the converse. Don't need to write the converse down at all. The converse just says if there's a point on the perpendicular on a line, that when you draw that perpendicular distance to the sides and that is congruent, then it's an angle bisector. Then these two angles are congruent to each other. Just the converse of it. Okay, the converse of that one is more confusing than anything. Okay, so again, this has to be perpendicular to the sides. Once it's perpendicular to the sides, then it's angle bisector. Not, it's not. So if we look at this one as an example, we want to find the value of x. Okay, so I look at NR. I notice that it's an angle bisector. From point R to M is perpendicular, and from part R to P is perpendicular. Since that happens, then MR has to be equal to RP. So 7x has to equal 2x plus 25. Subtract 2x from both sides. You get 5x equals 25. X is equal to 5. That's your solution, and you're done. Again, it's all about that theorem. We got to have that 90-degree angle. We have to have that angle being cut into two congruent pieces. Okay, so the converse of it then. Again, we're asked just to find the value of x. So now I'm given that MR and RP are congruent to each other, and they meet at a 90-degree angle. The converse to our angle bisector theorem says that because that happens, then NR is an angle bisector. Then angle MNR has to be equal to angle PNR. I died. Trouble with internet yesterday? Were you guys dropping internet a lot yesterday? So those two are congruent to each other. So 3x plus 17 has to equal 6x minus 40. Subtract 3x from both sides. Add 40. I know I'm kind of skipping steps with equations, but we should be getting good at those. So 57 equals 3x. That's an ugly number. That looks right, doesn't it? Oh, that works. So x is equal to 19 divided by 3. That's 19. So x is equal to 19. Couldn't figure out what it was. Needed a calculator. All right, I'm going to have you try one more, and then we'll call it a day. So this wants you to find the measure of BCD. So it wants you to find the measure of this whole angle right there. Knowing that CF is a perpendicular bisector and that those two parts have to equal each other, find the value of x and then find the measure of that large angle. See if you can do that one, and we'll call it a day. So those angles have to be equal to each other. So 3x plus 5 equals 8x minus 35. Subtract 3x. Add 35. So 40 equals 5x. Divide by 5. X is equal to 8. So the measure of this angle is 3 times 8 plus 5. So that's 24 plus 5, which is 29. The measure of this angle is 8 times 8 minus 35. So 64 minus 35, which is 29. So the measure of the whole thing is 29 plus 29. So the whole answer should have been 58 degrees. How'd we do? We do okay? So are we good with the first part of angle bisectors and perpendicular bisectors? So the assignment you're going to get today, there's 2 pages to it. There's 2 pages to the worksheet you're getting. One of them says perpendicular bisectors practice, and the other one says perpendicular bisector practice 2. You are doing perpendicular bisector practice today. Perpendicular bisector practice 2. That's what we're going to do on Thursday. Remember, tomorrow is a catch-up day. So if you have missing assessments, you're going to take any missing assessments. If you have any missing assignments from chapter 4, you're going to spend the day working on those missing assignments from chapter 4. But today, you've got the perpendicular bisector practice 1 is the one you're going to do, not the practice 2. Practice 2, we're going to wait a few days. Go. Good timing.